Okay, this is higher level apps, all of the hypothesis testing that you need to know. Apart from at the bottom there, you'll see chi-squared testing, which we haven't covered yet. Everything else we have though. So the majority of hypothesis testing is against claims made about the population mean. So we've got, in this case here, a bunch of bags of cashew nuts, and there's a huge amount of them in the population, millions and millions of them, and we don't know what their average weight is, but it does say on the packet that it's 100. But then somebody comes along and makes a claim about the population mean. They say, no, I think that it's less than that. So they're not specifying what it is, they're just simply saying it is less than a number. And so all we can do to test that claim is to take a sample and see if that has enough evidence in it to determine whether the claim is right or wrong. So we always set it up in the same way. We're going to make a null and alternative hypothesis. So the alternative hypothesis is normally the claim. And in this case it is. Somebody's saying it's less than 100. So we'll say, well, the neutral position that it is what it says on the pack, that it is 100. The null hypothesis is always an equal sign. And we're going to see which of these hypotheses we're going to accept. And so now we've decided this is a claim made against a population mean. It's one of these 5 things. What is telling us that it is not a Poisson? Well, the word Poisson is not used. So the Poisson will always be indicated. So it's not Poisson. How many samples did we take? Just the one. Here they sampled 40 bags and the average was 99.4. So it's not a 2 sample thing, it's a 1 sample. And so the only question you have to ask yourself is it Z or T based on, did they tell us the standard deviation of the population? Yes, they did. So this is a Z test. Dead easy test, Z, 1 sample, and you just fill it in almost exactly as we see it here. It is a null hypothesis of 100. We're talking about the alternative being less than. Standard deviation is 1.6. And the mean of the sample is 99.4. And there were 40 bags in the sample. And I can run that. And I get a very small p-value. And so that is 0.8%. 0.8% is less than the significance level of the question, which actually isn't stated there. Let's say it's 5%. And therefore I can safely reject the null hypothesis. And I can say there is evidence. The next one is another claim made about the population, that some bloke says that rainfall, which used to, we know, average at 93 millimeters per month over a large population, and this bloke reckons that it is more than that. So we'll see if there's evidence for that. So it's always easy to set up the null hypothesis. It is always equal to whatever the population used to be. And it is greater than 93 in this case. Nice to put units in, as you know, there are units here. And so then you decide which of these tests it is. Well, how many samples are there? There's just 1. So it's not Poisson again. So it's just a Z or T test. Did they tell us the standard deviation of the population? No. And so I type the data in, test, t-test. How many samples were there? Just the 1. And that is all very straightforward. I can go greater than 93. What did the average? Oh, well, okay, this one, we've actually got data. So I'll go to list and just run it. P-value is 28%. And therefore I accept the null hypothesis. There's not enough evidence. Next one. It's a real classic paired sample, before and after. So this is volunteer number 1 has done something. It took them 1.3 seconds, and then they've taken a drug, and then they do it again and they're faster. This is volunteer number 2, volunteer number 3. So they're paired by the fact it's the same person, and it's a classic before and after. And the way we handle this is by adding in the change to as a new variable. Let's say this guy's improved his speed by 0.1. So I am saying, what is the improvement here? That is that guy didn't improve. This guy's actually got worse, and that guy's got quite a lot faster. And now we have one variable, that one there. And so I can type that into the calculator and go back here, test, t-test, no mention of the population. Standard deviation, how many samples have I got? 1, because I'm interested in the change. Okay, so that's how you handle it. I typed in the change numbers there. Test, t, 1 sample, and what is the null hypothesis here? Now, what is the population? The population is all of the improvements people made, an infinite number of improvements between before and after. Now, we only sampled 5 of them, but the population is everybody, and so it will be 0. We're going to see if there's an improvement, and the claim is that there is an improvement. So I've got greater than there, even though reaction times are going downwards. The way I did the subtraction is that I have created a positive number there. That's up to you, it works both ways. And so I go to my calculator just to make sure everything is set up. The null hypothesis is 0, greater than, run it. It's a 15% p-value. There is not enough evidence to suggest this drug works. And that's because you've got a very low sample size. This time we've got our 2 samples, and we're comparing 2 products about which one has got less sugar. So we sample. Again, we've sampled 5 from one population and 5 from a different population. Okay, there's an infinite amount of mocha lights, and we've picked 5 of them, and there's a separate, independent bunch of chalky froths, and we've picked 5 of them. So the claim that's being made is of one population mean compared to another. And what we're saying is that the average of the mocha is less than the average of the chalky. So that's the alternative hypothesis. And this is the null hypothesis, a bit different to normal, because you normally expect to see equals a number here. But we're kind of saying the difference between the 2 means is 0. But this is how you set it up. We just type it in, test, t as usual. It is normally t. It is odd to be told the population standard deviation. 2 samples this time, and I've typed them into list 1 and list 2, and the only thing I have to tell the calculator is less than is my alternative hypothesis. Just ensure this setting is on, pooled is on. As long as it's on, you don't need to worry about it. Press enter. P-value is 20%, so whatever our significance level was, we are going to accept that null hypothesis. Okay, so that leaves Poisson and binomial and bivariate, which I'll do in the next video.